variation in the height and sea level pressure. Normal. I have to teach you what is adiabatic lapse rate. Okay? Adiabatic lapse rate I haven't taught you yet. I'll not teach you now. At least it will take 4 to 5 days. Because once I teach adiabatic lapse rate and normal lapse rate, then things will get confused. So let's first learn about cyclones. Today we'll complete the concept of global atmospheric circulation. Then we'll go to the secondary circulations and then tertiary circulations. Okay? After that, and then I'll come. Because still we are left with the concept of temperature inversion. Okay? Oh, okay. Firstly, very good evening online. Just give me a minute. So, Shaurya is asking me to take up. Please explain the topics that we have discussed on the globe. Okay, I'll explain. Apart from that, any other doubts which you have? Yes? No doubts? Okay. Okay, we have started the concepts of atmospheric circulation. Atmospheric circulation is nothing but how the winds move across and around the earth, right? And the winds are of 3 different types. First one is primary circulation, second is secondary circulation, third is tertiary circulation. The entire winds that are there on the surface of the earth are broadly classified like this. Primary circulation means those which are present all throughout the year. Secondary circulations are temporary in nature, they can be there for 5 days, 10 days, like that. And then tertiary circulations are local winds. In the morning, the winds can be in one direction, and in the evening, the winds can be in the other direction. Broadly, the entire wind which is there, that is broadly be classified into primary, secondary, and tertiary. This we have discussed in the last class. Any doubts here? Primary circulations are called planetary winds. I can call it as easterlies and westerlies. Secondary circulations are cyclones, which are temperate cyclones and tropical cyclones, and tertiary circulations are local winds. See, these local winds can be of many types. Across India, you look into, across the coastal region, you will find the winds as sea breeze, land breeze, that I'll explain after tropical cyclones and temperate cyclones. Right? Chinook, I've told you, you might have heard. Chinooks. Not the helicopters, but the winds. Chinooks are winds. Right? And Kal Baisakhi, West Bengal. Kal Baisakhi is in West Bengal. Punjab, nor'westers. Punjab region में लू, अभी currently जो हवा चल रहा है, which is so hot, that is called loo. Right? That loo is also a local wind, which is not present all throughout the year, but only in season. Maybe for 10 to 15 days it will be there, after that it is gone. It's a local wind. Mango showers, blossom showers. Mango showers in Kerala. See, before the monsoon comes into picture, monsoon usually comes to India on June 1st. But before the monsoons, in the month of April and May, you have rainfalls. Now, those rainfalls are because of the local conditions which are present in the Kerala. Now, these rainfalls because of convection. Convection is today the earth got heated so heat because of the sun, and then convectional cells took place. Then there will be a rainfall. Now, these rainfalls will give mango flowering. That's why they are called mango showers in Kerala. Go to Karnataka, such kind of rainfalls will help in flowering the coffee, or else blossoming the flowers of the coffee. You call it as blossom showers. Go to West Bengal, Kal Baisakhi. Okay? Loo in northwestern part of India. So these are some of the examples. And in Italy, Switzerland, you also have similar kind of winds by the name Fohn, F-O-H-N. Chinook in US. this we'll discuss after, maybe by tomorrow day end we'll be there. But today, this is what we are going to learn. Okay. And what else did we take up? Any doubts? Wherever you have high temperature, what kind of pressure do you have? Low pressure. Wherever you have low temperature, what kind of pressure you will have? High pressure. इसमें कोई doubt नहीं है. You're clear with this. Temperature high, then you will have low pressure. Temperature low, then you will have high pressure. Clear. This also we have discussed. And atmospheric pressure concept I have discussed yesterday. Right? Pressure should always be measured at equal heights. Right? Equal heights. Okay. Apart from that, we have also discussed about the vertical pressure. Vertical pressure is, I'll quickly review it, or else I'll quickly help you to revise it so that we can go ahead with the concepts. Right? So, in the yesterday's class, I told you that if this is the earth, and on this earth, what you are supposed to do is, you take a column. Column is, this is the column. Now what is the height here? This is tropopause, or where till the troposphere extends. Now always a person standing down will experience so much of weight of air which is lying in this column. Now the same person, if I am moving little higher into the atmosphere, this person, if I am moving him or her to higher heights, will they experience more pressure or less pressure? Less pressure, right? So in vertically, it is always, as you go higher into the atmosphere, will you experience high pressure or low pressure? The answer is outrightly low pressure, right? Now this is what is vertical, right? Now, other side, if you look here, when I take two different columns, okay, that is what is vertical pressure. And in the vertical pressure, I have also told you that friction is present till what height? Friction is present till 3 kilometers itself, right? Beyond 3 kilometers, there is absence of friction of air. That's why the air moves very fast. Okay? And any aeroplane which is moving, it always wants a clear weather. Okay? An aeroplane which is flying, it always wants to avoid clouds, turbulence. And see, on the Tibetan Plateau, no aeroplane will dare to travel on the Tibetan Plateau. You know? Why? It's shouting, actually. You know why? UV rays, but if someone is going to kill you, what do? You shout. Right? So that is the death sounds. Okay, come back. See, I told you that Tibet is one region, no aeroplane will dare to fly on the Tibet. High speed winds, but why do you have high speed winds on Tibet? इसके बारे में सोचना. Aeroplane would not like to travel in an area of high turbulence. ठीक है? Aeroplanes would not love to move in high turbulence areas. ठीक है? So that, just have a thought on this. Q aeroplanes will not travel on the Tibet. It is because of turbulence. But why do you have high turbulence on Tibet? It does not, not related with temperature. It is topography. ठीक है? See, Tibet, it is like this. See, this is your Tibet, broadly, right? Now, what is the average height of Himalayas? Greater Himalayas are 6 kilometers height. Now, at 6 kilometers height, what kind of pressure do you have as compared to the sea level? High, low? High, low? Vertical pressure. Low pressure. ठीक है? Vertical pressure is low. Comparatively, it depends. If Tibet is having more high temperature than the sea level, of course. Now, Tibet, on an average, the height of the Tibet is 4.5 kilometers. The height of the Tibet is 4.5 kilometers. Now on the Tibet, you can also find mountains. If there is a mountain on the Tibet, the height of that mountain will easily reach 5,000, 6,000 meters, even if it is 2,000. Now there is group of mountains. For example, if there is a wind that is traveling like this, let's imagine this is the wind. If it is traveling like this at a height of 6,000, 7,000 meters, don't you think this Himalayas will obstruct it? Of course it will obstruct. So sometimes the wind will move up, down, up, down. Okay? Now the air turbles. Okay? Suppose an aeroplane which wants to travel in this direction. Okay? Let's see. This aeroplane, while it is traveling in this height, it sometimes gets in touch with the fast flowing winds. So then it will start to shake. So that's why usually over the Himalayas, no aeroplane will dare to go. Okay? Even if at all they are trying to move, what do is they choose the height to be somewhere around 15, 16 kilometers, which is almost equivalent to 35,000 meters. Ladakh, Leh also. Only exceptional few corridors which are there, the aeroplanes will go there. It is because of the wind system. Right? So today, we'll learn about these winds also, which are fast flowing winds. They are jet streams. Yesterday, you got to learn about the primary circulation, which are called as local winds. Which are called as planetary winds. So before I move any further, ek aur baar, let's quickly move and discuss. If a wind is moving, what are the forces which will obstruct or which will help that wind to move? Any wind that is moving is influenced by the forces of gravitational force, friction. Friction is present only till 3 kilometers height. Next you have pressure gradient force. And yesterday I made you to write that if the distance between two isobars is less and the pressure gradient is more, what will be the wind speed? High speeds of the wind. Very good. Right? And last one is Coriolis force. Coriolis force, I already told you yesterday that in the northern hemisphere, any wind which is moving in any other direction, the Coriolis force deflection is towards right. The wind will deflect in this direction. Right? In the southern hemisphere, anything that is moving, be it birds, be it aeroplane, be it water, the oceanic currents, or anything that is flying, even the kites that you fly also. You cut the kites will also move, deflect themselves towards the left. So what is the left direction here? Instead of moving in this direction, what do? They deflect towards the left. They deflect towards the left. So this is how the deflection of the winds takes place. In the northern hemisphere, the deflection is towards the right. And in the southern hemisphere, the deflection is towards the left. Clear? Okay. I now will move forward with this content to explain you the global atmospheric circulation again. Okay? What we'll do is, we'll do it on the globe. Yesterday we did it on our yes. Yesterday we did it here. The same thing. Now let's imagine three-dimensionally and then discuss it. So I told you there can be pressure belts of two different types. What are they? Right? Okay. And have you been following the cyclone? Yes? Yes. Rimal. क्या हो रहा है रिमल में? What exactly is it you are finding there? Wind speeds. It is said that it has the potential to become a super cyclone. Okay? Please follow it so that your disaster management will become easier for you. You need to check Remal cyclone which is there in West Bengal and all. Already NDRF teams are being called in. Okay? Cyclone management is Odisha is best known for managing the cyclones. So Odisha is giving the expertise to West Bengal. That is interstate cooperation during the times of disasters. So try to look into it. Just a minute. Let it load. See, these are the winds which are present at 10 kilometers height. Okay? Now, all over the world, if I broadly show you, what is the speed of the wind? 156. And look over India, especially 17 kilometers. This you will get to understand why you have less speeds of winds, especially in the month of May and June, especially over this part of India. And the northern part of India is currently experiencing a speed of the winds to be around 150, 180, 290, like that. Now, we will be having these geography classes for another 15-20 days. Okay? By then, monsoon will be in. Okay? You will see a large-scale variation in these winds. Now, after 15-20 days, you will literally see these winds which are moving in this direction, they'll take a turn and come back to India. I want you to read the NCERT chapters of Indian geography. Okay? Indian geography, there is another NCERT. That is, this is not the one NCERT. In that, go and read the chapter of climate there. I'll come to the Indian geography there also, because monsoons and all, here itself I'll explain you. Right? So these winds, literally, what do is, they move in this direction and they turn like this. Now, why is this turn there? And what kind of impact is this winds getting onto India? You need to know it. Right? So, whatever I'm showing you at a height of, look at this height. The height here is almost 13.5 kilometers ki unchai par winds hai. These are not surface winds. Okay? Now, see here. These are the winds which are present at what height? 13 kilometers. Right? But if I show you the winds at the surface, look at these winds. They're not in the same direction. Why? You'll get to know by tomorrow day end or day after tomorrow. Right? So, here let's look out for the Remal. Yes. You should also look out for the Remal cyclone. Remal cyclone we'll discuss in little more detail. And I can also see another cyclone being developed in the South China Sea. Okay? This is one cyclone is in the development. So, look out for one. Sometimes the cyclones which are formed here, they'll cross the South China Sea and then also come into the interior of India. This we'll discuss in the cyclones chapter. Now, quickly come back to our atmospheric circulation. So, first thing to understand this, you know that wherever you have high temperatures, you'll have low pressure. Wherever you have low temperatures, you'll have high pressure. Right? So, this thing, ye to sabko clear hai? Come back. Now, I have told you that the temperatures broadly when you look into, it is like this. See, Earth has 7 pressure belts. Now, what are they? One at the equator. So, what I'll do is, Now, this will be more relevant to many of them. See, whatever I'm going to teach here, this is on an ideal condition. Ideal conditions means what? It means ऐसा होना चाहिए, लेकिन कभी ऐसा होता नहीं है. Why? Because our earth never stands still. It is continuously rotating. A person who is standing at the equator is moving faster. A person who is standing at the polar region is moving slower. Then why is the person who is near to the polar region experiences different circumstances? 6 months of absence of sunlight is there. 6 months of presence of sunlight is there here. And today in the North Pole on June 21st, you will see the northern pole, the northern hemisphere is full of sunlight. Right? June 21st is yet to be seen. We are actually moving to the most hottest days that is seen in the month of June. So what we'll do is on an ideal scale we'll study and we'll variate this by the end of this class. Right? Ideally, you see all throughout the year, if I take equator, this is the equatorial line and this is the place where I'll have high temperatures, right? So whenever I have high temperatures is equal to low pressure, low temperature is equal to high pressure. So all throughout the year as compared to the Tropic of Capricorn and Tropic of Cancer, either ways, it is so hot. So this is equatorial low pressure belt, right? And this equatorial low pressure belt, it is so hot. Next pressure belt which you will find is at the tropics or the subtropics. Subtropics means between 20 degrees latitude to 30 degrees north latitude. And this is the place where you will find an other latitude. See, as compared to equator, will you have high pressure, as compared to equator, will you have low temperature or high temperature if average temperatures are taken all throughout the year? Low temperature. मैंने क्या कहा था? During the months of summer in the Punjab, the temperatures will reach 45 degrees Celsius. But as soon as you come to winter, the temperatures are again 6, 7, 8. Right? When you take the average, the temperature is not more than 20. Okay? 15, 20, this is the average temperature. But equator, no matter summer, winter, whatever is the season, temperatures are minimum 35. Summers it will go to 48. Average अगर देखा जाए, equator is having high temperature. ठीक है? Tropic of Cancer is having low temperature. Likewise, at 23 degrees south, here you will also have another pressure belt which is developed that is called as subtropical high pressure belt. So I'll call this as subtropical. Yes, this is the ideal situation for the month of March and September. Okay? But I do not want to discuss that and make it complicated, so that I am making it easy for you to understand. Right? So this is, can I write like this? Subtropical high pressure belt. Subtropical high pressure belt. And this is subtropical high pressure belt in the southern hemisphere. Now come to polar region. Polar region is a region which has always cold temperatures. You take the average temperature at the 90 degrees north and 90 degrees south. Here the temperatures are always cold. So can I call this as polar high pressure belt? Yes, yeah, no? Yes. Because temperatures here are always low. So you will have high pressure. Right? Can I also call this polar region as polar high pressure belt? Right? Now, as compared to polar region, I'm talking about as compared to polar region, if you look into the subpolar region. Subpolar regions means those latitudes which are present at 66.5 degree latitude. So here the temperatures are not too cold like the one which you have seen at the polar region as compared to this. Right? And as compared to this polar region, here the temperatures are not too cold. So can I call this as subpolar low pressure belt? This is also subpolar low pressure belt. And see here, you know the logics. Wherever you have low pressure, what happens to the wind? Rises. Wherever you have high pressure, the wind sinks. Right? Now, if you are having low pressure, look here, the winds will start to rising, in the sense here you need to imagine in 3 dimension. The winds are rising like this. Right? The winds started to rise like this. And these winds which are rising, I cannot draw it in the air, so I am drawing it on the sideways. Likewise, here also the winds rise. Now those winds which have risen, they'll reach to the height of what? To the height of tropopause. 13, at equator it is 18 kilometers. So troposphere top layer tak jayega and then it diverges. Clear? What kind of pressure do you have in the high pressure belt? In the high pressure belt, the air always sinks. Am I drawing right? Yes. So, sinking air, as the air sinks, what does it do? It starts to diverge. Rising air rises and diverges. ठीक है? Rising air rises and diverges because on the upper side, what kind of pressure did you have here? Yes, very good. It's not here, here. Right? So, this air, as soon as it reaches, look here, this air, it is diverging in all the directions and it comes back to the equator. Right? So, look at this particular air between equator and subtropical high pressure belt. That is nothing but 0 degrees latitude and 23.5 degrees north and south latitudes. The winds are actually coming towards the equator, right? When the winds are coming towards the equator, any wind which is moving in the northern hemisphere, their Coriolis force direction is towards right. So, if suppose this is the wind, I'll exaggerate and I'll draw it. If this wind is coming in this direction, if the Coriolis force is towards the right, the wind, instead of going in the straight direction, it will turn towards its right. So, that means the wind deflects like this. Am I right? And the same winds for you, our convenience, what I'll do is I'll draw it little properly. ये जो winds है, as earth round है, the winds which are present here, they go all around the earth, right? Earth is continuously rotating, the wind is moving above the earth, and those winds which go around the earth will come back on the other side also. Got it? So this is east side and this is western side. US and all, we call it on the west, east, right? So do you find these winds to be traveling from east to west or west to east? That's why we call it as. And they are present in the northern hemisphere. That's why I'll call it as northeasterlies. Right? Same way in the southern hemisphere. Look at these winds. A wind which wants to move towards the equator because of the subtropical high pressure belt. Now the wind deflects towards which direction in the southern hemisphere? It's towards, Coriolis force is towards left. मैं थोड़ी देर पहले ही बताया था. In the last class also we have discussed that. That means the wind deflects like this. Right? The same winds. So, between Tropic of Cancer and Tropic of Capricorn, the winds are always easterlies. Right? They are easterlies. Right? So, I'll call this particular winds as As they are present in the southern hemisphere, I'll call them as got it. Next, come to the next cycle, and what is the name of this cell? Hadley is the one who have identified. That's why it is called as Hadley cell. Right? That means the winds are rising, and then they are rising 18 odd kilometers, they are sinking and then coming. So these are surface winds, and these are upper atmospheric winds. Right? And the region where equatorial low pressure belt is present, we call it as डोल ड्रम. ठीक है, यहाँ पे इतना गर्मी होता है, there's too much of heat that is present. Literally, equator, you look into your atlas. ठीक है, I hope you can also keep your atlas open. So when you look into your atlas, much of the equator which is present is actually present on the ocean. Only 25% of the area where the equator is present is land, where rest of the ocean is rest of the area is ocean. So because of which too much heat is there, then the water starts to evaporate, and all that is evaporated in the evening, it will come in the form of rainfall. Roz subah, early morning it will be so hot, by the evening the equator is cold. It is because of this rainfall that is falling in the evening. And this rainfall is called as convectional rainfall. And at equator, out of 365 days, 300 plus days it will have rain. Singapore is a city which is located next to the equator. It will experience rainfall on a daily basis almost for 300 odd days every day. ठीक है? Drainage systems, or the cities which are located near to the equator, their drainage system should be very strong. And I already told you, all those crops which need to be grown next to the equator, they need to be big trees, because small crops, they cannot survive there. The soil gets washed away, right? So similarly, the big trees which are there, plantation crops, they'll go for. Small crops, they cannot grow, right? Okay, this is Hadley cell. Now come to the polar cell. First we'll finish the polar cell, and then we'll come back to the Ferrel cell. So in the polar region, as you already know, that it is what? High pressure belt? Polar high pressure belt. So at high pressures, what kind of air do you see? Air rises or sinks? It is cool, so air sinks. So sinking air, this sinking air, it moves in all the directions like this. Now, Coriolis force is towards? In the north hemisphere, it is towards right. So it deflects like this. It deflects like this. Right? Are they appearing to be western winds or eastern winds? These are polar easterlies. Now these winds which have reached here slowly, so polar low pressure belt hai. Once they rise, they diverge on either sides. And likewise, this cell is also yes, sorry for the inconvenience. Yes. So this cell is called as polar cell, right? And this cell, it is ferrule cell. And yesterday's class I have already told you that there are thermally induced pressure belts. Thermally induced pressure belts means those pressure belts which are primarily formed because of temperature. So at equator, all throughout the year, the temperature is very high. So because of that, the wind, the air that is there, it is always hot. So low pressure system, this low pressure is primarily induced by that heat sun, hot sun. Likewise, here also at the polar region, the temperature is more or less this low. So it is also induced because of thermal reasons. So I call this as thermal pressure belt, this also as thermal pressure belt, and this, that is subpolar low pressure belt and subtropical high pressure belt as dynamically induced. Right? These two are dynamically induced. This is thermally plus dynamically induced. Dynamic means the factors can be any other factors. It is not only the temperature, it could be any other factor. It can be topography, it can be anthropogenic, it can be the vegetation that is present there, it can be anything. Right? Now come to the winds which are present in the latitudes of subtropical high pressure belt and subpolar low pressure belt. Right? Also please try to remember the latitudes. What is this? 0 to 5, north and south. What is this? 20 to 30. So usually 20 to 25 मान के चलो, 30 and all, you will find literally the westerlies will be there. Right? 25 मान के चलो ये. And this is 66. This is 90. So between 90 and 60, the winds are moving from east to west or west to east. East to west, ठीक है. Between 5 degrees north to 25 degrees north. Easterlies. 5 degrees north to 25 degrees south. 5 degrees north कहाँ था मैंने? If it is 5 degrees south to 25 degrees south, they are easterlies, southeasterlies. Right? Clear? If 5 degrees north I say, 5 degrees north, you will not find easterlies there. See, between 0 to 5 north and south, that is doldrum. In that doldrum, the winds are very calm. Again, no activity. You put a ship into it, the ship cannot move here and there. It will float. Simply floating here and there. And you already know, the temperatures are very high at the equator. Sea always evaporates. Sea always swells. Swells in the sense, the ship cannot move any further. And see, since last 2 decades or 2 centuries or so, we had machines. But people used to travel since last thousands of years, right? How did they travel? Waves को study करके, winds को study करके. ठीक है? Do you remember the old ships? They used to have a mast and then they used to tie it with a rope, hulls. ठीक है? Rope and that cloth होता था. Why is that cloth needed? Because they wanted to move in the wind's direction. ठीक है? You'll get to understand that after some time when I get into the monsoons topic. Now look here, half of India, can you see this India here? Half of India is having easterlies. Now other half, let's try to see this. Look at these winds. As these winds wanted to move towards the north, now what is the Coriolis force? Direction in the northern hemisphere is towards right. Right? So broadly, you look here. Now these winds, are they easterlies or westerlies? Because they are moving from west to east. So that means 50% of India is under the influence of easterlies, and almost 45 to 50% of India is under the influence of westerlies. Now, whatever the winds which we have studied, these are surface winds. Now, without drawing all of this, just draw an earth and on the latitudes I wanted to see the direction of the winds. ठीक है? If you want to take a photograph or so, whatever you can take. Yes? Does? Yes, tidal force works. Tides जो है, tides are formed because of the moon and the sun. ठीक है? Wind is just a generating force. Wind can create waves. Tides are actually created by the gravity pull of the moon and the sun. Doldrums में wind की कारण calm conditions होता है. ठीक है? But tide होगा. Now why tide? Give me 5 minutes, I'll explain it. Right? See, primarily, why tides occur on the earth? Irrespective, imagine there is no wind on the earth. Even then you will have tides. Here we are only discussing about the winds, right? So if you are done with this, then we'll move further and I'll address this doubt. Can I clear this? हाँ पूछो. See, now Shaurya's question is that, sir, he said, subtropical high pressure belt is there. Now this is present at a latitude of 25 degrees north. This is 66 degrees north latitude, and he says that subpolar low pressure belt which is there, as you compare these two, the temperature is high here and the temperature is low here. You are absolutely right. But is it a thermally induced pressure belt? Dynamic. So, if temperature is the factor which is influencing the pressure belt to be formed, then under that conditions, you are true. But I already said this is dynamic. This is also dynamic. In the dynamic areas, it is not the temperature which is deciding that this pressure belt should be formed. ठीक है? In fact, this is a stronger pressure belt and this is also a stronger pressure belt. So this stronger pressure belt forced subtropical high pressure belt to form. And this strong pressure belt called polar high pressure belt, this very strong polar high pressure belt is the reason why you get to see the subpolar low pressure belt. ठीक है? So, if I am more stronger, I'll try to attract you. Right? But if the person who is staying far away from me, it is very difficult for me to attract him. Rather, another strong pressure belt which is located near to that particular person will try to attract. So, in fact, this is not a permanent belt. This is not a permanent belt. These two are permanent belts. Got it? Now, broadly, this is how the wind starts to move from one place to another place. They are primarily frictional force which is there. Every wind which is there is experiencing the frictional force up till 3 kilometers and 4 kilometers. Beyond that, no friction. When there is no friction, it is a free rider. It can go anywhere. That's the reason why the wind which is moving at the surface moves slowly. And the wind which is present at 8 to 10 kilometers higher, it moves at a speed of 200, 300 kilometers. But, in between two cells, see, I am going to enter into an area which is little more complicated. Now, this is little more complicated area is considered to be an advanced geography. Now, this advanced geography is called as jet streams. I'll be introducing the concept of jet streams now, but I won't teach the jet streams now. After we complete the primary and secondary circulations, then I'll teach the jet streams. So, there are couple of jet streams which are present in the northern hemisphere, which are permanent in nature. Now, what are these jet streams? Jet streams are three-dimensional winds. Now, what is this three-dimensional wind? Which has length, which has breadth, which has width. ठीक है? You have a pipe in the early, maybe at your home, you garden sometimes, you might have a water pipe, right? Imagine there is a wind which is present at a height of 8 to 13 kilometers high. Now this is 8 to 13 kilometers height. Now this wind which is there, it will start to meander like this. And this meandering wind which goes around the earth. ठीक है? Likewise, between Hadley cell and Ferrel cell and polar cell, you will have winds which are moving at a height of 8 to 10 kilometers, and they always move from unidirectionally. Now, which direction and all, I'll tell you. Right? Between Hadley cell and Ferrel cell, you will also have another jet stream. Let's call this jet stream as subtropical jet stream. Okay? I know it is complicated, but please be patient. I'll explain all of these things. It takes little time because we are just entering into the next level of geography. So from here on, you see, okay? Now these are jet streams. We did not have the knowledge of these jet streams which are present at 8 to 13 kilometers height until the Second World War. Okay? How did we get to know about this? We never launched a satellite until 1960s. We only got to know about these jet streams when USSR, actually Russia, wants to go and attack the other countries. Okay? Between the Allied and Axis, they wanted to fire. So in one direction when they were moving, for example, all these jet streams, they move from west to east. Okay? Look here, is there a jet stream which is present over India? Yes? They move from west to east, okay, at a height of 13 kilometers. Where does aeroplanes move? Same height, 30,000 feet or 35,000 feet. And the aeroplanes, while they are moving, if they are moving from west to east, they are traveling faster. But when they wanted to move in the opposite direction, their speeds get reduced. So USSR got shocked when it wants to send its aeroplanes. In one direction, they are moving faster. And in the other direction, while they wanted to launch their rockets and all, they are missing the targets. And they are running out of the fuels and they are losing their soldiers. They thought that this is done by Japan. This is something that is worried. Then later on, they got to learn that since 1935 itself, the Japanese scientists, they were aware of the jet streams. And they used to use these jet streams to attack USA. Right? So they were very smart. It's just that we did not know about all of this knowledge. And see, India, it is very important because these jet streams actually help get monsoons to India. Now, I'll be taking off this diagram. If you want to take photographs or whatsoever, please quickly take. Because if I touch the screen, it will be gone. We anyways have the replicated diagram on the board itself. Dono monsoons ko it will affect. It will affect the southwest monsoons also. It will affect the western disturbances also. Okay? How it affects, I'll tell you. Just give me some time. Because we will go as per the flow. Right? Shaurya's question is, sir, which pressure belt is stronger and which pressure belt is weaker? How do we get to know? In simple terms, if the temperature of the local region is so hot, then the pressure will be low. Okay? Thermally induced. It is like that. Now, see here. I have the real-time data of the winds that are moving over. Okay? Now, his question is, sir, these jet streams which are there, are they going to impact southwest monsoons or are they going to impact the northeast monsoons? Okay? See, basically, India has two monsoons. One, this is equator, right? During the times of summer, look at these winds. We are currently in summer, right? So this is your equator. Easterlies, the wind should be southeasterlies, right? This is how the wind should be. Are they in the right position? सही डायरेक्शन में तो आ रहा है ना? अरे ईस्टर्लीज नो. चलो, I'll draw like this. right? Now, as soon as these winds, when they cross the equator, what is the direction of the Coriolis force? The Coriolis force in the northern hemisphere is towards the right, and the Coriolis force in the southern hemisphere is towards the left. So, the same winds, when they have crossed the equator, the Coriolis force is towards the right. Right? So, that's why this is north of India, this is south of India, this is east of India, this is west of India. So, the monsoons that they come to India during the months of June, they are called as south or western part of India se enter karta hai. That's why we name it as the June month monsoon, southwest. Clear? But the same monsoons during the time of December, January also we will have. Those monsoons, they enter from this part of the region. But this monsoon will come in the month of Jan, December. How and all? I have to explain few more concepts to understand the concept of monsoon, because the knowledge that I have given you, it is not sufficient. This is just an introduction into monsoons topic. Now, he has two doubts. One regarding, sir, the tides, will the tidal waves or tides be present at the equator when there are no winds? Okay, I'll address that. And the second one, he asks, sir, what is the role of the jet stream? Now, look here. These are surface winds. If I take you to the upper atmospheric winds, okay? See, I'll be taking off this. Try to remember the winds, how they are traveling now. I'll take you to an altitude of 10 kilometers. This is the real-time data. Okay? We have a pro version of the windy, so that's why I'm able to show you. Now look at the direction of the winds. Jet stream. ठीक है, यही तो है jet stream. It is three-dimensional jet stream. This wind which is there. Now look into your diagrams, the one which you have drawn as a jet stream. So this is nothing but a jet stream which is moving over India at a height of 13 kilometers height. Now this jet stream will also impact the monsoon. How? Now what are the winds I am showing you? These are the winds which are present at a height of 13 kilometers. So, see here, you have Tibet somewhere here. Now what is the average height of the Tibet? 4.5 kilometers. Already Tibet एक table है. इस table गर्म हो गया तो low pressure बनेगा. Now the air will start to rise, and all the air that rises, what does it do? Now let's see this nature of the jet stream. Imagine this is a jet stream. A part of this jet stream, what happens is that, so look here, this jet stream while it is traveling, it will come in contact with this system. Okay? Once it comes in contact with the system, while it is moving, see, Coriolis force is towards right or left in the northern hemisphere? Right? So as it moves, it tilts towards the right. Okay? Some part of the jet stream comes in this direction, and some part of the jet stream will move in this direction. Okay? In your NCRTs, if you come across anyone has the Indian Geography NCRT? Anyone? India Physical Geography. Not that one. Other one. Yes. You have it. That one. In this book. So I'll deal in very detail about the monsoons and the jet streams as he asked me the route. That's why I've landed here. But these are little complicated topics. I'll explain them little later. So in this book, it will be written as, regarding the monsoons, that at 15 degrees north, the wind starts to move. Just a minute. see this diagram. They have shown it as winds which are moving in this direction, eastern direction. Okay? For online, let me show it to them. Okay? The winds are shown in this direction. You can also pass on to everyone so that they'll have a look into this diagram. They'll showcase this as see, these winds which are there, what did they do? They took a turn and they are coming on to India. Okay? While they come on to India, what do? Is they drag any cyclone which is formed here, they drag on to India. Okay? So, if I close up, can you see this movement of the wind which is going here and slowly a part of it has taken a turn? Slowly, a part of this wind has taken a turn and coming in. This is nothing but the same jet stream has taken a turn here. This is subtropical westerly jet stream. It is coming from the west. And the same jet stream, as it comes onto from the eastern side, this is called as subtropical easterly jet stream. Right? Now this will impact the monsoon. How? Simply any depression or any wind system which is there, it will drag on to India. Agar hawa evaporate ho raha hai, garam hawa, that will be dragged on to India. Yes, they carry moisture. Okay? These are fast flowing winds, they carry moisture. Now this becomes a daunting task for the aviation industry during the months of June. Okay? During the months of June, you see, anyone who wants to travel from India to China or anyone who wants to travel from India to Ulaanbaatar is the Mongolia capital. इस मौसम में ना flight का tickets always they touch the skies, especially in this time period. It is primarily because you have Tibetan plateau which is present here. And on the Tibetan plateau you have these mountains. अब ये सोचो, what is the speed of this one wind? Let me try to show you. 170-200 kilometers. If suppose an aeroplane is traveling in the same direction, मक्खन की तरह भागेगा. ठीक है? But if an aeroplane is trying to move in the opposite direction, problematic and turbulence भी होगा. Right? Now, just imagine about the aeroplane which wants to cross these jet streams. So it's a daunting task. And one more thing. This is called a no-fly zone. Especially the Tibetan region is called a no-fly zone primarily because in the no-fly zones and all, you won't find any airports nearby. Okay? No fuel stations, no runways. If suppose due to turbulence, any technical issue comes, they had to travel another 1,000 miles or 500, 700 miles. So that's why no one would like to enter into this part of the area. And look at the speeds here. 234 kilometers, 235. ये है jet stream, a three-dimensional wind है. In simple terms, three-dimension means you need to imagine it like this. एक pipe की तरह. Literally, earth के in and around there are few pipes. हाँ हाँ आप कर सकते हो. Just a minute. This is how you have jet streams. ठीक है? We'll discuss this about in little more detail. See, geography has 3 stages of geography. One, I consider one as basic geography, one as advanced geography, and the third one as applied geography. ठीक है? Whatever we have discussed, this is just an introduction into jet streams. I did not tell you how jet streams form. I did not tell you how the jet streams move. I only said there are jet streams present. I even did not tell you how they move with seasons. All of these things I'll explain in the further classes, not today. Right? So, this comes under applied part. decide applied geography. Basic geography is what is high pressure, what is low pressure. Advanced geography is because of this high pressure and low pressure, how the wind moves. Right? Now one more question one of our friend asked is, sir, do you have the impact of, as near to the equator, I said that 0 to 5 degrees, there is too much of evaporation. Now when you have too much of evaporation, what happens is that, see, every day there are convectional cells that are present. Look at this diagram. This is 0 degrees. ठीक है, ये है आपका equator. Now at the equator, if this side, if you cannot see the board, you can also shift on to this side. ठीक है, यहाँ पे clouds है ना, continuously there will be evaporation. Why? One reason I told you, at equator the land is less and the water is more, and there is more amount of heat that is present. So at 40 degrees of an average temperature during the months of summer and 30 degrees of average temperature during the months of winter, it is considered to be high temperature. So because of that, the winds that have risen will give you super good rainfall in a matter of 1 hour, and the clouds that are developed are cumulonimbus clouds, which has the potential to give rainfall and thunderstorms. Ice crystals. तो ये रोज की कहानी है वहां पर. ठीक है. Now his question is, there are no winds present, will they impact the waves? See, tides. Tides are primarily formed because of two reasons. See, I have an earth. Imagine this is a celestial body, and this celestial body is completely made up of solid. ठीक है? I have another celestial body. Celestial body means just imagine an earth. ठीक है? I have another celestial body which is completely made up of water. ठीक है? And again, I have another body, third body. And this body is bigger than these two bodies. So, don't you think that it will have its gravity impact on these two bodies? Yes, it does. Now let's imagine this is your sun, and this is Earth 1, and this is an Earth 2. For our understanding, to make the topic little more simpler, I am giving you this hypothetical situation. So, if this is solid, the particles which are there, are they tightly packed or loosely packed? Very tightly packed. In the water, the molecules are loosely packed. So first suppose, if this body tries to attack both of them, who will be moving? Water body. Right? Simple hai. Now why the waves come? Waves come into picture, tides come into picture. If suppose, now just imagine you have your earth. ठीक है? This is your earth. Earth has mountains, earth has plains, earth has plateaus, and earth also has oceans, and these oceans are present like this. And these oceans are filled with water. If this body is trying to pull this mass, will the water move or the solid move? Of course, water gets pulled out, right? The water, they get pulled out like this. Got it? So, tides do not have their direct relationship with waves and winds. Okay? Wind can increase the size of the tide, no doubt. But wind alone will not create tide. In the tide, the water rises and falls. In a wave, the water, in which direction the water moves? What is the motion of the water? पहले ये बताओ, what is a tide and what is a wave? How are they different? ठीक है, tide is rise and fall. अभी तो बताया था हमें. Wave क्या होता है फिर? Will the water move in the waves? If I am speaking, how are you able to hear? Wave. ठीक है. What kind of wave did it hear? Did it reach you? Sound wave. I spoke from my voice box. This created a sound wave, and it went and vibrated in your ears. Wave is nothing but an energy which I transferred from my voice box reached to your ears. Wave is always transfer of energy. ठीक है? Wave is the transfer of energy. If water is moving from one place to another place, it is not wave, it is current. ठीक है? In the wave, you will literally see the water moves like this. Just imagine this is your ocean. I am talking about the movement of the water particles. Imagine this is a water particle. The water particle literally in the waves, while it is moving forward, it rises and then falls. The wave water particle will come backward. It is like this. It rises, falls, and then come backward. In fact, the water moves circulatory motion. ठीक है? Wave में water वहीं पर होता है. Hardly the water will move for 20 meters. It goes and it comes back. If suppose this water particle or the water which is there, if it has shifted from this position to this position, it is not because of the wave. It is because of the current. ठीक है? Wave is the transfer of energy. That means the energy from this place is transferred to another place, but not the water. ठीक है? In the current, the water moves. So, tide, the water simply rises and falls. They rise and they fall. It is like this. The water rises and they fall. Now, this is called as tide. This tide is created because of earth and moon. How? I'll explain in the oceanography. Next. Wave is transfer of energy. ठीक है? That is the fundamental difference. अब थोड़ा बहुत हवा ज़्यादा होगा, इसका हाइट ज़्यादा हो सकता है, बट अगर हवा ना होने से फिर भी this tide can be there. So at equator, you will also have good number of tides. I hope you got this. So are you clear with the tricellular model circulation or else the atmospheric circulation? Can you quickly draw in your notes? If suppose this is my earth, this is equator, this is Tropic of Cancer, this is Arctic Circle, this is Tropic of Capricorn, and this is Antarctic Circle. Now please show me the direction of the winds on the earth. Yes. I don't want all the circles to be drawn. I just simply want the direction of the winds. ठीक है, this is how you'll get to see. In the polar region also, what kind of winds do you have? Polar easterlies, and literally your polar easterlies are east to west winds. They are literally east to west winds. ठीक है, यहाँ पे तो थोड़ा बहुत नॉर्थ साउथ हॉरिजॉन्टल मोशन होता है, but in the polar regions it is literally easterlies, polar easterlies. Here also you will find right? These are polar easterlies. Then you have and one more thing. See, between this 0 to 5 degrees north and south, doldrum region, there's every day cloud formation that takes place, and these cloud formations, they also give rainfall, right? And this doldrum is the region where it's not that easy to cross doldrum region using a ship. Okay? See, I told you that last 200 years or so we have machines. The greatest innovation that this earth has seen is steam engine. Okay? Because of that steam engine, they are able to run the engines, and then they run the machines, and that machine is doing a lot of work. All the way from anything that you wear and anything that you use today, it is used by machines. But the mode of energy has changed. The mode of mechanism has changed. But my question is, how did Vasco da Gama cross that sea and came to India? Trade winds. I told you there are no winds here. How did this Vasco da Gama cross India? And look at this. He came, the route which he used is this. He came from here. He crossed this equator and then came all the way south, Cape. यहाँ से यहाँ आया. देखो, trade winds, if you have trade winds, from here to here, you can do trade. We have very good relationship with Arabia and Africa. The trades are very easy from this direction. Because यहाँ पे equator है, the winds usually move like this, right? This is what is southwest monsoon. It is easy for them to travel. But how did this fellow, all the way from Europe, had crossed equator and then came south? Literally, it was his luck. Why was that? No one, since 11th century or so, Magna Carta is there. That was the time they became democratic, right? So, at the time of Magna Carta, they wanted to explore the world. They wanted to find where it is. In search of India, they went and found that USA, okay, Columbus. There was a ship by the name Magellan ship. They were trying to find the sea routes across the globe. They know that India, there is a land route, but land route is too harsh because they have to cross through desert, okay, big deserts. And how much volume of cargo they can transport? Only little volume. But if you have trade routes through sea route, it is easy for you to transport large amounts. So this Vasco da Gama, he's lucky fellow, because it was his ship which was stuck in this particular equator for near about 15 to 20 days. He was floating in that area, and somehow the weather conditions favored him, and after he crossed with near about 80 odd people, he lost everyone except 4 people. Then stayed in the Cape. He was waiting for a good hope, met the Arab travelers in Africa. क्योंकि Arab travelers already know that there is monsoon winds, that they come during the months of June. चलो हम जून में चलते हैं, इंडिया चलेंगे, and वहाँ से spices we take it up, and that spices will be brought back to Africa. From Africa they used to do the trade route. But now, shipping and all, while going back, he came with 2 boats, lost 1 boat in between, and the other boat, he lost everyone there except for 4 people, and finally reached India. While going back, he was offered ships from India, and then he went back, find out routes, and with stronger boats, again they waited for the floating to happen, waited for another 10-15 days there, finally reached back. So he is the one who have told that this is the sea route and these are the seasons that you can come through. That's why he is rewarded well. ठीक है? Next time he came with almost 600 fleet. ठीक है? 600 fleet के साथ आया था उन्होंने, with small boats, big boats, and mechanization also, small scale mechanizations. And then they used to cross this equator, and that is what a new era of navigation started. ठीक है? But geography should favor them, and somehow it has favored them. It's not that easy. And also, at the equator, the height of the sea is little higher. You know that? Yes. Suppose if I have water filled in this glass, and if I start to give heat to this water, what happens? Water spills out. Why water spills out? Thermal expansion. You heat anything, the body expands. Of the entire globe, where do you find more heat? Equator. That's why the height of the sea at the equator, it is like this. If I broadly draw it, your sea height will be more here. ठीक है? Yes. That is why the height of the sea is 8 centimeters more as compared to the rest of the ocean. ठीक है? So in NCERTs also it is written somewhere in a passing reference that the oceanic height is little higher here. And this height, it will not let any ships to travel that easily, because look at the curvature. Just imagine the earth to be like this. Instead of that, I'll turn the earth like this. Okay, now try to look into the sea. The sea height is a ship which is there. It has to travel. So once they cross the equator, it is easy for them. Okay, geographically speaking. Right? And the winds will also favor them, because easterlies are there, like that. Okay. Now, any doubts which you have in the tricellular model circulation? So, can you imagine the winds now on the earth? On an ideal scale, we are looking into these winds. So, आपको हमेशा ना, to make geography little easier for you, you have to imagine the earth in 3 dimensions only. Suppose if I am drawing a circle here, it does not mean the circle. It should be in your imaginations that this is the earth. Right? Now, easterlies, the winds are on this direction. Right? Here also you have easterlies. Here you have westerlies. Okay? Again you have easterlies here. Right? Same way. Westerlies. Again easterlies. So you have more winds of easterlies on the earth or more winds of westerlies on the earth? Easterlies सबसे ज़्यादा होता है. ठीक है? The easterly winds are more. And between each of this belt, you have a separate stream of wind that is flowing. That is your jet streams. This topic I'll explain later. ठीक है? But these jet streams are present at what height? 8 to 13 kilometers. Wobble friction नहीं है. He says that, sir, why is it Rossby? मतलब up and down. It is because at 13 kilometers height there is no friction. ठीक है? Turbulence. Topography also matters. कहीं बीच में mountain आ गया मान के चलो. If there is wind that is moving, but the mountain which came in between. So this wind will rise. The entire stream of wind which is there above, it will start. And also, this jet stream which is there, it has this Rossby-ness. Every week it moves. Today it can be like this. Next week the shape will not be the same. It is because of local temperatures on the earth. टोपोग्राफी कारण हो सकता है. वाई एंड ऑल विल डिस्कस इन द एडवांस एंड अप्लाइड ज्योग्राफी. ठीक है, अभी जस्ट लर्न दैट देर आर जेट स्ट्रीम्स लाइक दिस. नाउ बिटवीन दिस जेट स्ट्रीम्स यू हैव विंड्स मूविंग इन दिस डायरेक्शन. नाउ वंस यू नो दिस बेसिक कॉन्सेप्ट्स it will be easy. So our democratic time period has been completed. मैंने कहा था एक हफ्ते पहले I'll be moving very slow, but since last 2 classes I've been indicating you that chalo let's move little faster. I hope everyone is able to understand this, right? Clear? Now once you are done with this, we'll go to the secondary circulation. ठीक है? Now what is secondary circulation? हाँ, I told you that winds can be broadly be classified into 3 different types: primary, secondary, and tertiary. Right? Primary circulations are easterlies, westerlies. Jet streams are also part of primary circulations. ठीक है? And also, but they are advanced winds. I have to give you an introduction into this jet streams also. See, the advanced study of this jet streams took place only in the year 2000s. Though we are having this idea of jet streams since Second World War, but we started to study in little more detail in the year 2000, because these jet streams sometimes used to impact the launching of the satellites as well. They burn the fuel more. Okay? And sometimes what we did was, see, the World Meteorological Organization even went on to identify a team which can study the jet streams, that is aviation jet stream. Why? Because they wanted to save the fuel. They used to use these jet streams and they used to save the fuel. And one more thing, jet streams are not present at equator. Jet streams are not present at equator. Remember this. Jet streams are present between Hadley cell and Ferrel cell and polar cell. Right? It is like this. हाँ, basically river की तरह. बस. It is exactly like a river, the jet streams are, which has Rossby waves, sine wave, a pipe, or a snake which is moving in the air. It is like that. ठीक है? Characteristics अगर देखा जाए jet stream में, see, satellites can use the jet streams, aeroplanes, aviation industry can use the jet streams, even birds identify these jet streams, and they migrate with the help of these jet streams. They flow in the direction of the jet streams, and these jet streams are, few are permanent in nature, few are temporary in nature. The monsoonal jet streams which you get to see over India, they help get good monsoons to India, and if the jet streams fail, the monsoons also fail sometimes. ठीक है? Jet streams decide the heat also. You might have come across a word called polar vortex. कभी सुना होगा करंट अफेयर्स में, या फिर अगले कुछ टाइम पे आपको सुनने में मिलेगा व्हाट इज पोलर वोर्टेक्स. ठीक है? और एल्स घर जाके चेक करना व्हाट इज पोलर वोर्टेक्स. राइट? यू विल गेट टू अंडरस्टैंड दिस. पोलर वोर्टेक्स, आई विल एक्सप्लेन दिस इन द अप्लाइड. फ्रॉम टुडे only 3 days I need to complete the advanced geography, and then we'll go and play with the applied part. ठीक है? And for those students who are new here, please ask. We have been there conceptually for 4 odd classes we have completed conceptually. So get the access and watch that classes first, because these classes are continuous to the previous topics. Geography is one such kind of a topic. It becomes easier as we complete the classes. ठीक है? So let's quickly move to the secondary circulation. So secondary circulations are cyclones. They can be tropical in nature, or they are found in tropical areas. They can also be found in temperate areas. So like turbulence in Singapore airline. Yes, the turbulence in Singapore airline is also the same reason. It is Rossby waves. Can pressure belts change? Yes. So Munendra has asked a question here online. Can pressure belts change? Yes? Yes, they can change. They are not permanent. ठीक है? सन के साथ हर दिन चेंज होते रहते हैं, ठीक है. Yes, in the first classes we have learned about the apparent movement of the sun. During the months of June 21st, the direct sun rays is on Tropic of Cancer. June बोला था मैंने. June 21st is Tropic of Cancer, and December it is Tropic of Capricorn. So these pressure belts also, they keep on moving. I'll explain that after some time, during the times of monsoon. Right. Now let's quickly move into the secondary circulation, that is your tropical and temperate cyclone, how they are formed. And current affairs mein remal cyclone is going on. I asked you to please go and read the newspapers daily, how the disasters are being managed and how this management takes place. Now before I move into this cyclone, how many of you have experienced a cyclone? At least how many of you have experienced a disaster? You were there in disaster management class. ठीक है. Floods. और कोई? हीट वेव चल रहा है ना, वो डिजास्टर ही है, ठीक है. कोल्ड वेव एक्सपीरियंस किया, इट इज ऑल्सो अ डिजास्टर. फ्लड्स और एल्स अर्थक्वेक्स, बट disasters are something when it creates large scale damage which is irreparable with your immediate capacity. ठीक है. A large scale damage which is irreparable with your immediate capacity. मतलब मान के चलो आपने घर बनाया, it takes near about 20-25 years of your hard work, hard earned money, and if that house gets dilapidated or collapsed, with the immediate funds that you have, you cannot rebuild, right? You have to seek help here, there. Now that is a disaster for you. ठीक है. You will call it as a disaster only when the potential which you have, with immediate potential, you are not able to revive it, right? That is what is called as disaster. So basically heat waves and all will create disasters, large scale disasters, cold waves. So one such disaster is also your cyclone. ठीक है. Now what is a cyclone? How can you define a cyclone? अंदर लो प्रेशर है, बाहर हाई प्रेशर है. उसके अलावा ठीक है, जिसने एनसीईआरटी पढ़ा उनका कहना है देयर इज आई वॉल, ठीक है, दैट इज स्ट्रक्चर ऑफ ए साइक्लोन. बट व्हाट इज साइक्लोन? हाउ डू यू डिफाइन साइक्लोन? हाउ डू यू डिफाइन साइक्लोन? आर साइक्लोन्स फॉर्म्ड ओनली ऑन द लैंड or cyclones formed only on the ocean? Both? Yes. ठीक है. Temperate cyclones can be formed on the land and they can be formed on the sea. But tropical cyclones, they can only be formed on the sea itself. They cannot be formed on the land. Right? So now what we'll be discussing is about tropical cyclones. Now what are tropical cyclones? See here. Those cyclones which are formed between, look at this, these two areas. And I have a small homework for you. Homework or a small question which I want you to ponder upon while you come to tomorrow's class. You will not have cyclones between 0 degrees to 5 degrees north. Why? Because you will not find Coriolis force near to the equator. ठीक है? That means we are going to discuss about the tropical cyclones, the cyclones that can be formed in the Bay of Bengal, a cyclone that can be formed in the Arabian Sea, or else a cyclone that can be formed in the South China Sea, or any of this area. ठीक है? Now, first I'll give you what do you find in the news articles. Since last 1.5 years or 2 years, it is said that the frequency of cyclones which are found in the Arabian Sea are increasing. ठीक है? Number one. Usually, Bay of Bengal has the highest number of cyclones. But I am telling you, news articles since last 3 to 6 months have been studying that the frequency, the number has not, in total number अगर देखा जाए, it is Bay of Bengal the highest number of cyclones you will find in the tropical areas. But since last 10 years, it is said that the frequency of cyclones in the Arabian Sea are increasing. Why? This can be a question that can be asked in your exam. Okay? Okay. For that, let's try to understand first what is a cyclone. See, if I have to declare a disaster in an atmosphere, or if I have to declare as a disaster which is in the aquatic area, okay? And I have cyclone. Will I be declaring this particular cyclone as a disaster in aquatic area or disaster in the atmospheric area? ठीक है, डिजास्टर तो डिक्लेयर करेंगे, चलो मान के चलो हम डिजास्टर डिक्लेयर करने वाले हैं. नाउ शुड आई डिक्लेयर इट एज एन एटमॉस्फेरिक डिजास्टर, शुड आई डिक्लेयर इट एज एन एक्वेटिक डिजास्टर? बोथ. चलो अब डिस्ट्रिक्ट मैजिस्ट्रेट हो ओडिशा का, एक भुवनेश्वर, you have been alerted by the Indian Meteorological Department that there is a cyclone that is going to come and hit you in the next 5 days. Prepare yourself. This is literally the letter that will be written by the Indian Meteorological Department. Red color, green, red color, yellow color, 4 codes will be there. They'll say that red code. Right? Now this is a case study that will be asked in your GS paper 4 also. What are the steps that you are going to take? See, actually, cyclone definition is a low pressure area that has the potential to create winds more than 60 kilometers per hour. ठीक है? Cyclone is an atmospheric disaster. Cyclone is nothing but a low pressure area with intensified low pressures or depressions that has the potential to create more than 60 kilometers per hour wind. It is an atmospheric disaster, but that has a potential to create storm surges. Now, what is this storm surge? What is a storm surge? Yes? Electricity to nahi hai. Chalo, I'll show you a small image of the storm surge. Before I go into the cyclones, I wanted to discuss about the disasters of the cyclones, because cyclones are also related with the disaster management. These two are integrated. So recently, in the last year, we got to see a cyclone. This cyclone has created a storm surge, not in India, but in the US. ठीक है? Just a minute. See, literally, when cyclones are looked from the space, they look like this. ठीक है? Structure अगर देखा जाए, see, always geography has a perspective. ठीक है? If the author is writing from this aerial view, you have to look and understand the topic from the aerial view. It's not that you standing on the ground, you're trying to understand that cyclone. It does not work like that, right? Usually, in your textbooks and all, the cyclones are always said that there is an eye, and this eye has an eyeball, and the cyclone is actually represented like this. Well, it is not. It is represented like this. It always spirals. ठीक है? This is your eye, and it has an eyeball, and it has wings. Right? This is the real-time images of the cyclones. So whenever there is a cyclone, sometimes this cyclone, when it comes and hits the coast with great speeds, it can bring seawater onto the land. ठीक है? This is the diagram which is given in your NCERT. But how do you are supposed to see this cyclone? That matters a lot. See, this diagram which is there, you are looking from the space. Right? But this diagram, you are looking in a cross-sectional view. Where is your eye? This is the eye. If you are standing on the top, this is the view. But this is nothing but a cross-sectional view. You are standing here and watching the cyclone here. Right? So, whenever there is a cyclone, sometimes the cyclone has the potential to bring in storm surges. The video which I have is St. Helens. It is on the west coast of USA, where the storm surge came immediately after the cyclone. It is not tsunami. When cyclone comes and hits the coastlines, sometimes the wind speeds are too high. They can bring in the oceanic water onto the land. This is the real-time footage again. Now, imagine what kind of impact this can bring in. Loss of life, of course. Yes. See, basically, cyclone will always bring in immediate risk and also a risks that are associated after 1 month. कैसे? नमक का पानी, salt water. This salt water enters into water bodies. The drainage water which is there in India, most of the times, you see, only cities like Chandigarh, you are blessed to be here, has sewerage system. ठीक है? Rest of the places in India, it has sewage system. Sewage and sewerage system, the fundamental difference is sewerage is closed, sewage is open. ठीक है? Now the sewage, all the water that entered into the sewage systems, what do? Mix हो गया अभी, खिचड़ी बन गई. So you will see the spillovers everywhere. There's no concept of fresh water, there's no concept of salt water. It takes at least another 40-45 days for the ground to settle back. Now imagine you have agriculture farm fields of rice, wheat or whatever it is. Will they survive? They cannot survive just because the salt water came in, gone. Right? Waterborne diseases. And it has long-term diseases also. So that's why immediately after a rainfall or heavy rainfalls, flooding, or even the storm surges, the municipal corporation will flush in the bleaching, chlorine dal dete, taki bacteria and anything which is there, it should go. But because of that chlorine, the cost of your ROs at your home, the filters get spoiled very quickly, your taps get spoiled very quickly, and they start to scold, "Arey chlorine dal diya." ठीक है? These are the problems of the middle class. Right? Now, at the end, imagine you are the district magistrate, what kind of steps you are going to take. I am the Indian Meteorological Department. I told you that there is a cyclonic alert which is red in nature. I can tell you that it can bring in storm surge. ठीक है? What steps will you take? Firstly, immediate committee, you'll take in the immediate committee. First is you have to think of identifying the low-lying areas and evacuation, and then you will also talk to schools, colleges, grounds, jitne bhi hai, high-rise areas, you will talk to them. And later on, food, immediately you have to make sure that relief hona chahiye. This relief should at least be there for another 10 days. You don't know how things work here. Right? Communication you need to set up. Right? Volunteers you need to have. Boats you need to have. You'll call in NDRF, you'll call in SDRF, State Disaster Response Force, Relief Force. And you need funds also to rebuild all of these things. Electricity is gone. There's no connection. Right? Think of kids, think of pregnant women. There is a hospital which is located next to this area. And you are the district magistrate. सारा सिरदर्दी आपके पास होता है. ठीक है? You think of all the problems are with you. You also have the administration, you have to handle that. So the concept of cyclones that we are going to discuss, it is not just conceptual in nature. It can be asked as a case study. ठीक है? Flooding is an aquatic disaster. ठीक है? But cyclone is an atmospheric disaster. Now this disaster, cyclone, has the potential of both aquatic as well as atmospheric, or else atmospheric disaster which has the potential to drive the atmospheric disaster which has the potential to drive the aquatic disasters as well. So please also look it from the disaster management angle also. Right? Now we'll move into the cyclone topic in detail. How does a cyclone form? ठीक है? Here I am going to discuss about tropical cyclone first. ठीक है? Tropical cyclones are present between Tropic of Cancer and Tropic of Capricorn. Sometimes they go north and south of the Tropic of Cancer, but they face the consequences. ठीक है? What kind of consequences? I'll tell you. They become notorious when these cyclones move north and south of it. So, first one, tropical cyclone. See, for a tropical cyclone to be formed, it needs 5 conditions. First one, This tropical cyclone can only be formed on water. ठीक है? As soon as it touches the land, it loses its energy. Right? Firstly, a large sea surface. ठीक है? And this sea surface should have a temperature of more than ठीक है? First condition is it at least needs 27 degrees of Celsius. Second one, Coriolis force should be there. Third one, less wind shear. I'll explain what are this. Just keep on writing. And the last one is upper divergence of the air above the sea level. Right? These are the bare minimum requirements for the formation of a cyclone. Now, first thing is that a large sea surface area with a surface temperature of at least 27 degrees Celsius. Now, this 27 degrees Celsius should be at least, the temperature of the water should be at least for 100 to 150 meters depth. Okay? It is like this. Now, imagine this is your ocean. Okay? Now this ocean, it needs a temperature of 27 degrees Celsius for near about 100 or 150 meters का depth जो है वो पानी पूरा 27 degrees Celsius होना चाहिए. Now once the water starts to evaporate, what kind of pressure is this? This is low pressure area. When there is evaporation taking place, of course, its temperature is high, the water starts to evaporate. Right? As you already know, wind always moves from high pressure to low pressure. Okay? Wind always moves from high pressure to low pressure. If I am saying that this is a low pressure, what does that indicate? This entire area will start to rise. This low pressure means maybe in and around regions such as there could be a high pressure here, there could be a high pressure here, or there could be a high pressure here. In all the directions there could be a high pressure, or else as compared to all other areas, this area is low pressure. Now the wind starts to move in from every direction. Yes, towards this. Right? Now, let's try to first look into the conditions here. You got to understand the first point. Second one is Coriolis force. Coriolis force is absent at the equator. Okay? Remember this as a fact. In the further classes, I will tell you why. A weak pre-existing low pressure. Pre-existing low pressure means compared to other regions, you need to have at least a little low pressure area in that region. Less wind shear. Now what do you mean by wind shear? If the wind at the surface is moving in this direction, and maybe after 3 kilometers height, if the wind is moving in this direction, there is a shear. This is called wind shear. If the wind is moving in this direction and the upper atmosphere is also more or less moving in this direction, there is no wind shear. So there should be absence of wind shear. The wind should not be moving in different directions at different heights. Right? Less wind shear should be there. And the last one is upper divergence of air above the sea level. Now what do you mean by upper divergence of the air above the sea level? See, if suppose the air that is rising and this air, if suppose it has reached till the height of the tropopause, just imagine that the air is not diverging. What happens? Now what I mean to say is that what you said is right. Shaurya says that sir convectional cell ही नहीं बनेगा. But let's not complicate it. Let's make little more easier. If suppose if the air that is not rising, any air that rises, it has to diverge, right? Right? And if that air is not diverging, what happens? Troposphere के ऊपर नहीं जा सकता air. This air cannot go beyond troposphere. बारिश होगा, लेकिन किस टाइप का बारिश होगा? Very good. It is convective rainfall. It is nothing but जो equator के पास हो रहा है. ठीक है? Basically, if there is too much of heat that is present in this region, and if the air that is rising, and if the air is not expanding outward or else diverging outward like this, what happens is that they'll turn into a cumulonimbus cloud. Very large cloud which is all the way from the surface till the top. Now these cumulonimbus clouds, they burst themselves out. Cloud burst भी हो सकता है. ठीक है? So it is always the air should be having upper divergence. Now see here, these are some of the conditions for the formation of the cyclone. Now whatever the cyclone you are seeing here, you are actually watching on the coastline. Just imagine you're sitting on the beach and this is the ocean. You're watching in a cross-sectional view. ठीक है? You're watching in a cross-sectional view. But for the same cyclone, if you're watching from the top view, from the space if you look, it does look like this. But now we are looking into the cross-sectional view. Right? So see here, the air starts to rise. Now air that has risen, it starts to diverge outward, right? Imagine, look at this glass. The air starts to rise in this glass. Now the wind will start to diverge in every direction. But some amount of the wind, don't you think that it will also diverge into the glass? Possibility hai? Kyun? Because I'm putting my hand over here. Imagine my hand is nothing but tropopause. Tropopause is nothing but the place where troposphere ends. ठीक है? So some amount of the air will also go back into this glass. Why? Because the divergence happens in every direction. Some into the glass also. I hope you are able to understand what I am trying to tell. So look here. This divergence which is happening, it is happening in every direction. Right? Some of the air is actually blocked by the tropopause, and here some air diverges into also, and this air is now being blocked by the tropopause and they are forced to sink downward. ठीक है? This air is now forced to sink downward. Got it? Clear? So broadly you look into, this is the air that is rising. Got it? Tropopause ko, Shaurya asked me a question, why it is not crossing tropopause. Do you remember I asked a question one day, if I am closing this glass, what are the gases which are present in this glass? Only oxygen. There is 78% of nitrogen in this, 21% of oxygen, and 0.03% of carbon dioxide and argon. Now this combination of gas cannot get cooled beyond a particular temperature. ठीक है? This combination of gases cannot be cooled beyond a particular temperature. If they are getting cooled beyond a temperature, they will change their form. फॉर्म मतलब समझिए, ये गैस की तरह नहीं रहेगा, वो कुछ और बन जाता है. अब इमेजिन दिस इज सी लेवल 0 meters, दिस इज 13 kilometers हाइट. ठीक है? जस्ट लेट्स ट्राई टू अंडरस्टैंड शौर्या's क्वेश्चन. दिस इज 0 kilometers or 0 meters and this is 13 kilometers height. If the temperature is 20 degrees Celsius here, sorry, temperature here is 27 degrees 28 मान के चलो. शौर्या आप बताओ यहाँ पे टेम्परेचर क्या होगा? For every 1 kilometer, the temperature is reducing by 6.5 degrees Celsius. That means this gas which is there, this rising air is nothing but a combination of water vapor and gases. Beyond this, this gas cannot cool. If it is cooling, here the temperatures are almost minus 50 degrees Celsius. ठीक है? Beyond that, they cannot cool. That's why tropopause layer के ऊपर, beyond that, the air cannot go. If it is going, either it should be your ozone or it should be a rarefied gases which has changed some kind of form. It could be like that. I hope you got this. Okay. Jet stream इधर ही होता है. ठीक है? Jet stream is within the troposphere. ठीक है? Beyond that, you will find ozone here. Ozone is here. Okay. Now see, this cyclone, continuously it is getting heat, right? Now as and when it is continuously getting that moisture, water vapor, so here the clouds will start to form. ठीक है? धीरे धीरे clouds बनने लगता है, like this. Right? The clouds, the air that is moving, it will start to move. And these clouds, they become a band. Because they are becoming denser and denser, so they become bands. These are the nature of the clouds. ठीक है? This is a cloud. But the clouds are not generating here. In fact, they are rising and they are developing the clouds on the either sides. So, this band of clouds which are there, now together with the band of clouds on either sides, and this, the place where the air is sinking, is called as eye. And the place where rest of the area, the difference between eye and other area, this is called as an eye wall. Right? This is called eye wall. And this area where inward sinking of air is happening, you'll call it as eye. So the air that is sinking, is it gaining the temperature or losing the temperature? The air that is sinking, is it gaining the temperature or losing the temperature? Gaining or losing? See, gaining means if it is minus 10, it will be minus 9, minus 8, minus 6, 3, 2, 1, 3, 4, 5, 6, 7. What I told, the temperature here is minus 50 degrees Celsius. It is actually gaining the temperature as and when it starts to sink. It is subsiding, right? As and when it is subsiding, is it getting warmer or colder? It is getting warmer. So that's the reason why we call it as, this green color air, we call it as subsiding warm air. Right? Now this subsiding warm air is calm. ठीक है? The conditions are very calm. It will not disturb you. But rest of the areas which you are seeing here, they are band of clouds, and these are cumulonimbus clouds. So like this, there will be clouds that will be developed, and there's a big system that is formed. Okay? Now such a big system, you need to understand these are secondary winds. Do you remember yesterday I told you that only when the primary circulation fails, then comes in secondary circulation. When secondary circulation fails, then comes in primary circulations. Then comes in tertiary circulation. ये ध्यान से याद रखना. When primary circulation fails, that means easterlies and westerlies which are there, if they fail at a particular region, not across the globe, at a particular region, there evolves these secondary circulations. Okay? Now this primary circulation which is there, a cyclone is formed, a low pressure, itna low pressure hai, all the air from the surface is rushing into this area, and they are rising and they are forming as a cloud. Right? Now this system, just imagine, is present in the Bay of Bengal. ठीक है? Right? Is this system under the influence of easterlies or westerlies? So आप बताओ, what kind of winds do you find here? Our cyclone is under the influence of easterlies, right? When you look into this on a global scale, this is just a chotu motu system which is present in our which is present in our Bay of Bengal. And don't you think that this entire system will be traveling towards India? Now, for suppose, if there is a cyclone which is formed in the Arabian Sea, will it come towards India or will it go away from India? Away from India. Right? Those cyclones which are formed in the Bay of Bengal, they'll come to India and hit on the east coast. Those cyclones which are formed on the Arabian Sea, they'll go and hit Pakistan, they'll go and hit Oman, Yemen. So, इसीलिए all the countries which are present in this area, don't you think they have to work in tandem with each other? The meteorological department should help each other so that they can cooperate with each other. इसीलिए we do maritime exercises. इसीलिए we do combined the meteorological department helpful data share करते रहता है. This data need to be shared, right? For example, we named this cyclone as Sita, and someone named the Pakistan do not like Sita. She'll name it as Nilofer, right? So they will say that Nilofer has these characteristics. India says that Sita has these characteristics. Now, when you compare the data, mismatches can be there. So that's why it is said that all the countries in this part of the region, chalo hum naming karte. That naming should be in common with each other. That means what I'll do is, India will give 13 set of names, Pakistan will give 13 set of names, Oman, Yemen, all these countries will give their own names. Now, each name will be picked from one country, and the next cyclone which is going to come, I'll say that it is from Pakistan, it will be named by Pakistan. The next cyclone which is going to be formed in this region, Oman will name it. Okay? Like that, countries will cooperate and name so that the data is shared, so that for the future we'll have reference. If this is the pressure that is being developed, then that kind of impact can be there on the coastline. So the district magistrates who are there, they have to take care of these parameters. Right? So a cyclone which is being formed, it has an impact on the coastlines, fishermen's, also the coastal areas. Right? Now come back. This is a system which is under the influence of easterlies. So if suppose, if this entire system, if it is moving from in this direction, okay? If it is moving in this direction, will it experience Coriolis force in the northern hemisphere? Experience to karega hi. The Coriolis force deflection is towards what? Right? That means if this cyclone, will it move in the same latitude? No. In other words, See, look at this latitude or a line. Just imagine this is a cyclone which is developed here. Now this cyclone will not go and hit here. The cyclone will go, take a turn. Coriolis force is towards the right, it will go and hit here. Today we have the technology where what is the speed of the wind that is traveling there? Satellites will measure. What is the temperatures? We have the barometers, pressure thermometers set up in the Indian Ocean. We are so advanced in managing the cyclones. So a cyclone which is formed at 10 degrees north latitude will not go and hit the coast at 10 degrees latitude. Rather, it takes a turn towards the right and it goes and hits somewhere in the north. And today we will be able to identify which place it is going to hit. And the place where it hits, we call it as landfall. Okay? The place where cyclone goes and hits the land is called as landfall. Now, this cyclone is getting its energy from where? Where is this cyclone is getting its energy? Very good. The cyclone is getting its energy from the ocean, that too, from the oceanic heat. As soon as this cyclone comes and hits the coast, its energy source is gone, right? Basically, until and unless the cyclone is in the ocean and the temperatures are more than 27 degrees Celsius, there is continuous evaporation that is taking place. That evaporation which is taking place is nothing but which is making the clouds, right? Clouds of the cyclone. So, if you are going to cut the source of this energy, then the cyclone dies. As soon as this tropical cyclone comes and hits the coastline, the cyclone dies. But the cyclone structure, if you go and understand, it is not that easy. The cyclone structure and the relationships of the attitudes of the people also you need to know. Let's try to understand this. Now, are you clear with that? If I say the cyclone is under the influence of easterlies, only when the primary circulations fail, then the secondary circulations comes into picture? Fail, it is because of local conditions. Okay? Dekho, Shaurya's question is repeating for the online. Shaurya asked, how do we get to know that primary circulations fail? And हमें कैसे पता चलेगा ये fail हो रहा है कि नहीं? See, today, all the countries which are there in the Indian Ocean region, they have formed an association. They wanted to monitor the cyclones because a cyclone which is originating in the South China Sea can come and hit India. A cyclone, when it is formed near to India, if India tells that if a fisherman's while they are going in, they will be pulled towards that region because all the winds will move to that region, right? In the low pressure. So fishermen are the first people who will identify it. Or else, today we have satellite data. Using that, we are able to identify. Oman may not have a satellite reach till here. India can have the satellite reach till here. Right? India's NAVIC system has a satellite reach till here. But we do not have our satellite reach in this region. We need the help of the Southeast Asia. That if they say that cyclone is developed here, now India will keep a watch. Right? Now, how do we get to know that primary circulations fail? Maybe the temperatures in that part of the region is more. When the temperatures are more, they will also change the pressure system. The root cause is the temperature, right? Maybe there are coral reefs which are present here. You have washed away all the coral reefs. Sand mining ज़्यादा किया आपने. That might lead to increase in the temperature. Andaman Nicobar, you have cut down the forests. That will create more. Or else, Himalayan melting is taking place more faster. Here, Himalayas which are there has fresh water. Now this fresh water, Ganga, the melting of glaciers, Brahmaputra and other rivers, more and more fresh water is being discharged into the Arabian Sea. I have a glass of salty water. I have a glass of fresh water. Which water will get heated fast? Fresh water. Arabian Sea and Bay of Bengal, you compare, more fresh water is being discharged into the Bay of Bengal. That's why the water which is there in the Bay of Bengal will heat faster. That's why more number of cyclones in the Bay of Bengal. Now, because of the climate change, you have learned that the glaciers are getting melted. Now these glaciers can increase the number of cyclones, right? So overall, it has a far-reaching impact. The causes is, the parameters that we have discussed is conditions. 5 conditions are bare minimum. But the root cause of the conditions can be melting glaciers because of the climate change. Now why climate change? You are using more AC. He is producing more industrial wastage, more carbon dioxide into the atmosphere. Maybe you burn more fossil fuel. These are collective things. Okay? So, cyclical aspects. Now, broadly, when you come back, this system, for our understanding, what I'll do is, I'll call this part of the system as wing A. I'll call this as I, and I'll call this as wing B. Okay? I'm calling this as wings only for our reference. Okay? No authors calls them. I'm taking the liberty to call them to make it easy for you. See, now this entire system of cyclone, it is moving from east to the west. Okay? From this direction to this direction. Imagine the cyclone as and when it goes and hits here, right? Maybe one or the other place. Instead of a straight line, Coriolis foresight might hit here. And as soon as the cyclone hits here, it is called as landfall. So, देखो, कई बार क्या होता है ना, cyclone के लिए सबसे ज़्यादा ज़रूरी है. The most important thing is called as awareness. Now, why awareness? See, imagine the cyclone has come and hit this part of the coast. Right? Here you will see very fast moving winds, rainfall, thunderstorms, lightnings. So sometimes the excess rainfall and excess speed of the wind can also bring in storm surges to this region. Right? ठीक है. If the width of this cyclone can be somewhere around 250 kilometers also, 200 kilometers also. Right? At least it will take 2 hours, 3 hours to move away from this region, right? The system, I'll call this as a cyclonic system. Imagine the cyclonic system has moved inside. As soon as this reaches the coastlines, the source is dead. What is the source? Source was the low pressure which is there in the water. Now, imagine that our friend is standing here, and this friend who is there experiencing large cyclonic impacts, rainfall and all. But as soon as the eye comes into this part of the region, imagine the cyclone has moved little more inside. Now our friend who is there, he is currently under the eye. See, eye is considered to be a very calm region because the air is sinking. Sinking air is a region where you will find clear sky. It feels like the hard times are over, now let's go out for a date. But it never happens like that. See, here there is rainfall, but in this part of the region, the sky is very clear. Okay? Itna clear hai, you feel that, chalo, it is so clear, now everyone will start to do the normal operations. Right? Once they start their normal operations, there is another wing which is waiting. And this wing will be moving more faster, you know. Why? Because this entire system is under the influence of easterlies. If I have a very big system, it is little heavier. But I have a smaller system now. Right? The other side, B wing. This B wing will create havoc. So everyone will think that, chalo, abhi time ho gaya, the weather is clear, let's go out for work. Maybe for 1-2 days it is raining. And all of a sudden, you get exhausted, bahut din ho gaya, matlab bahut time ho gaya, ghar pe hai. Then you go out, electric poles fall down, trees fall down when this particular wing comes and hits the coastline. This will create a lot of disasters. It is because lack of awareness. The awareness is generally there for people who are the fishermen because they regularly deal with that. The educated people do not know. Even those people who are sitting in this class, at least 70% of them, they don't even know the concept of the cyclone. Now you imagine being a district magistrate explaining all of this thing to them. Simply what you will say, tell me the time of the eye reaching to the coastal areas. You will strictly say that, you'll create an awareness, radio, TV and all. You'll say, please do not venture out when there is clear skies. बारिश ज़्यादा हो सकता है, right? You will say, all the government officers and the private officers, shed them for the next 24 hours. You will pass an order. Emergency services which are there, keep them on standby. Civil hospital में beds बढ़ाओ ताकि ज़्यादा लोग आ सकता है. Doctors को छुट्टी मत दो. Call them back. Disaster management angle, you will see the municipal corporation, you increase the strength of the contract workers. क्यों? नाला ओपन करना है, the water should be moving. Electricity department, keep it on high alert because poles are going to fall, then you need to take care. So likewise, you have different departments at your hand, at your fingertips. You have to hold them and handle them during these situations. It is not just about the knowledge that you gain in this geography, but think of, there is a national park which is present here. How are you going to handle it? National park has trees, animals. Will you go and catch a tiger to save it? क्या करना चाहिए फिर? देखो, prevention is always better than cure. So, tsunami में हमें ये सिखा दिया 2004 में. See, back in 2004, when there was large-scale tsunami, we started to plant mangroves across the coastal lines. So mangroves are considered to be one of the finest solutions to stop this harsh moving winds. Okay, harsh moving waves. Mangroves will stop it. What you need to do is, across the coastal areas of India, start to plant mangroves. If not now, down the line 10 years, they will start to help you. Right? That is a precautionary measure. Now, if you have national parks and all, you have to plant a tree line. Tree line in the sense, if you imagine that you have a national park here. See, humans and all, they can get shelter, but animals, shelter is very difficult at the time of cyclones. Especially, you see the Vishakhapatnam area. There is a Indira Gandhi Zoological Park. Basically, it is a zoo, but it is one of the biggest zoos of the southern part of India. Cyclone Hudud came and hit that coastal area. 50% of the animals lost their life. And there were no birds until next 6 months. They had to reintroduce. Some of the animals, their shelter is gone. They have to rebuild the shelter. It took near about 4 years to revive that zoo again. Maybe within no time, another cyclone comes, gone. So that's why you need to create a tree line. That strong tree line should be there. Local plantations need to be taken place. Artificial corals, but how come corals are going to help you? To an extent, but corals, no, corals will get destroyed. Usually in the case of cyclones, corals get large scale destruction because corals में क्या होता है, temperature variations will be there. Corals cannot survive more than 27 degrees Celsius, firstly. ठीक है? Corals are present between 25 to 18. That is the temperature. So instead of corals, it could be a artificial something you can develop. So usually on the coastlines of many of the coastlines, what do they do is triangulated rocks. Have you seen across the coastal areas? These rocks you can place as a barriers. Usually, these are artificial embankments. Maybe in order to not to lose the coastal areas, sand and all. These are something you can think of. But coral reefs to nahi. He says that, sir, can we target the low pressure area? See, the width of the low pressure area is somewhere around 40 kilometers. So, we can do, humans are possible to do, they can do anything, but do we have that potential and the cost? Do we have the cost bearing capacity? See, your idea is good, no doubt. Hypothetically, it is possible. There are ideas that are proposed to combat climate change. How you know? They wanted to plant big mirrors as big as the size of Chandigarh in the space. Whenever there is too much temperature, these mirrors will reflect the sun rays. And they'll regulate the temperature. And that mirrors will act as an energy source, and through that electricity will be given. Hypothetically possible, but this idea can be implemented in the extreme case of the existence of human life. Okay? These are some things that can be hypothetical ideas that you can. Instead, aware the people. Okay? Awareness is the best thing. And cyclones are nothing new. They were there since the beginning of the oceans that are there. And humans regulate them. Cyclones will come, will go. No, not an issue. Hardly we need to take care of for 1 or 2 days. Usually these cyclones come in the month of August, September. Okay? And in the October it will peak. Why? It is because, again, if I have a glass of water, and imagine this is a brick, this is solid. Okay? A glass of water, and imagine the bottle size which is solid is also of the same size of this glass. If I start to give the heat, who will get heated first? Is it the solid or the liquid? Solid will get heated first. The liquid get heated later. It actually takes time to get heated. June May, the entire India, the entire India gets heated in the month of June, July. Water will take little more time. It takes near about a month or so later, and then tab hoga garam. So by June, our India will get heated, and especially 21st of June, this is the line where highest temperatures are there. But in the month of August, September, and in October, the highest temperatures of the sea will be there. September, October, you see, now we are in the month of May. September, October is not too far. You have the knowledge. You'll get to see at least 5 to 6 cyclones here and there. Now also you are seeing the cyclones, right? Remal cyclone, which is currently located in the Bay of Bengal. यहाँ पर है, Bangladesh. You go and look into the yesterday's newspaper and today's newspaper. This Remal cyclone is present here, right? So it is awareness that you have to create and make sure that cyclones are handled well. So UPSC has asked a question on this formation of cyclones. Punjab PCS also asked the questions. Ye favorite area hai, either for Punjab PCS, for UPSC or any state PCS examination. Now, when you are looking this cyclone from the space, see, if this is a low pressure, whatever I am teaching you, you are now supposed to look from the space. If this is low pressure, all the winds come to the low pressure from high pressure regions, right? Am I correct? That means comparatively this is a high pressure region, no? I hope you are able to understand. Imagine there is a low pressure system that is developed, which you are looking from the space. The winds will start to move in this direction. Right? Same thing I have drawn here. Coriolis force will be experienced which direction in the northern hemisphere? So for this is northern hemisphere and this is southern hemisphere. ठीक है? So it is towards right. All the winds will deflect towards the right. Circulation देखो, is it clockwise or anti-clockwise? Clock tick 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 tick, it moves in this direction. It is northern hemisphere, right? It is like this. And cyclones in the southern hemisphere. Any cyclone which is formed in the southern hemisphere. This is southern hemisphere. This is northern hemisphere. Now let's try to understand this. Coriolis force in the southern hemisphere is towards left. So kul milake, you look, the cyclone seems to be rotating in cyclones in the northern hemisphere rotate anti-clockwise, and cyclones, that is tropical cyclones in the southern hemisphere, rotate clockwise. Now this is how the cyclonic rotations will be there, right? हाँ, spiral सा बन जाता है. That is why your images are like this. This is cyclone. Literally this is the real image. ठीक है, screenshot लिया था from Himawari 8 satellite. This is I. Rotation देखो. The cyclone rotates. While it is moving, it rotates also. Right? Now this is what is your tropical cyclone. Tomorrow we'll discuss more about the tropical cyclone. It is regarding the administrative side. The cyclones will have different names. It is called as Willy Willys, it is called as typhoons, it is called as hurricanes. Hurricanes next to USA, and Willy Willys in Australia, typhoons in Japan and all. Principle is same, but they are called with different names. Along with that, you should also learn that why are few cyclones not formed in this part of the region, especially in the Pacific Ocean, the cyclones are not formed. That I have to explain, and we have to discuss the concept of ITCZ. I haven't discussed yet. Okay? That immediately after this concept of temperate cyclones tomorrow we will do. That is the most complicated topic. I always feels that ये जो textbook लिखा है, especially the temperate cyclone concept, that is what they have done. After 2 pegs they have written this book. ठीक है? It should have written in a very easy manner. NCERT, I don't know why they have done this. So injustice to the geography. Very easy topics, but they fail to make these concepts easy here. So, मतलब काफी अच्छा book है, content अच्छा है, but you could have made it for the class 11 or 12. These books are written as if the books are written for a PhD guy or a graduation guy. Even a graduate student cannot understand all of these things. Okay. So, majorly cyclones जो है ना अक्टूबर से लेकर मई के बीच में बनता है. These things we'll discuss, and also the largest cyclone, the longest cyclone. The cyclone which started somewhere in the Indian Ocean and went into the southern hemisphere also. That cyclones we'll discuss. For tomorrow's topic, we also have the color coding of the cyclone. Now what do you mean by color coding? So for each of this cyclone, you will be given certain color codings. Just a minute. Based on the damage, color codings and all will be given. So red color agar indicate kiya by the IMD, what are you supposed to do? Yellow color, what are you supposed to do as a DM? These questions can be asked. Now cyclones topic can be asked in GS paper 1 and in GS paper 3. From the disaster management side in GS paper 3, from the geography side in paper 1. And prelims में लिख के ले लो मेरे से, एक क्वेश्चन तो जरूर होगा. अब एक prelims examination is in the month of May, June, right? Either from the atmosphere angle or from the cyclone angle or clockwise, anti-clockwise. Somewhere or the other you'll have questions in this atmosphere area. Since the last 5 days, whatever we are discussing, you'll at least find 3 to 4 questions in the prelims. You mark my words, June 16th, I myself will be standing here and discussing the paper. In this class, at least you will be able to solve what are the topics we have discussed. 100% you will be able to solve the questions. Be it from the clouds, be it from the atmosphere, high pressure, low pressure, or the Big Bang theory that we have discussed in these topics. right? We'll stop here and tomorrow we'll continue with it. If you're attending tomorrow's class, please take the access online there. Please watch yesterday's class and day before yesterday's class. I think that is 1x या 2x speed पे देख लेना ताकि आपको basics समझ में आएगा for those students who are new here, right? Thank you and see you online. And any doubts, drop a message here. I'll answer. और ये मेरा नंबर बाहर शेयर मत करना यार प्लीज, ठीक है? ओके So why cyclone emerges in Bay of Bengal more compared to the Arabian Sea? It is because of the fresh water is more in the Bay of Bengal, so that fresh water can get heated easily 27 degrees Celsius, easily attain kar sakte. That's the reason why. Thank you and we'll meet tomorrow. Thank you.